Hi, 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 it's Sarah again, Welcome back to our ArchViz workflow series. Last time we finished a basic upscale, but today we are diving into the magical world of refinement. We're gonna look at the secret weapons you didn't even know you needed. Pixel space denoise, mask attention, segments to tiles, the enrichment pipe, noise injection, and deeper, way deeper understanding of all fusion methods. And drumroll, the mighty all-in-one workflow from denoising, refinement, and upscaling in a simple single pipeline. By the end of this, you'll be able to set up the TBG Enhanced Upscaler and Refiner like a pro and upscale your ArchViz renders into crispy, seamless masterpieces where even each leaf and tiny window frame has its own personality. Excited? I am! So grab your coffee and let's dive in. This one took me a bit longer, okay? I had about 9,000 questions minimum for my poor software team, and we ended up tweaking, poking, and mutating the node while making the video. So yeah, you might spot a few baby inconsistencies between the nodes on screen. That's just the price of progress, darling. Anyway, don't forget to grab the shiny new version 1.08 v3 if you actually want all these sparkly features. Here's where we stopped last time. A simple 2x upscale, nothing too fancy. No refinement, no detail control yet. Nice, but not a dot of what we can do for real ArchViz production. Today, we're taking this exact image and running it through the different ways of refinement TBG Enhanced Upscaler and Refiner offers. But before we jump in, we need to understand the techniques behind it, especially Fusion. Because once you know, you might have already tried other tile-based upscalers in ComfyUI, Ultimate SD Upscaler, Mac Bodhi, the predecessor of TBG Eater, the tiled upscaler script, tiled diffusion, SeedVR2 tiling, TTP, Secure, CCSR, and others. They all use the same trick to stitch tiles together, a gradual transparent overlap. Basically, the software takes each tile, applies a transparent gradient along the edges, and overlaps them, like gluing pieces of wallpaper at the seams. I was honestly surprised to see this because we're working with AI-generated images. Why rely on such old-school techniques? Now, the classic feather mask-based upscalers do a decent job if you keep things simple, but the moment your tiles get a little too creative, boom, welcome to Artifact City. Suddenly your trees look like haunted broccoli and ghostly seams run through your walls. That's why high denoise upscaling with new elements is basically impossible with this old-school method. Great for low denoise consistency, but not if you want fireworks. But for low denoise consistent upscales, it's okay. To give you all options, we included these methods in the TBG Enhanced Tiled Upscaler and Refiner Pro. Think of soft merge as classic upscaling plus fine-tuning. It acts like USDU, but optimized for newer models like QN, Flux, and Seedreams 4. And spoiler, we are looking into Seedreams 4 and Nano Banana integration right now. Now, refinement is where the magic happens. We're taking the image from part 1, tossing it into the load image node, and voila, a better starting point, way more detail, and yep, way better results. Oh, and way more fun too. Before we dive in, we need to understand the techniques behind this, because once you know how it works, you'll be able to troubleshoot on your own. We'll start with soft merge, run some tests, then move on to tile fusion, and finally explore Neuro Generative Tile Fusion. Along the way, we'll also introduce a few additional features. You can easily activate the same technique, composition mask blur, just select soft merge. And the best part? This works without the pro settings. You don't need a subscription, just disable PRO settings in the Upscaler and Tiler node, and all will switch automatically to soft merge. Here at the bottom of the Upscaler and Tiler node, you can set up composition mask blur or feather mask. And at the mask preview, you can see what happens behind the scenes. The red shows the feather mask, the black line is the overlap. By changing these values, you directly control how tiles blend. Let's generate some tiles. First, we set a low denoise. Let's try 0.3. In the preview of the refiner node, you can observe that each tile is sampled fully, corner to corner. They're blended together with no fusion, nothing is cropped. We just overlay the red marked areas when creating the final image. This also means these tiles don't have any information or idea what's going on around them. Even the overlapping area is sampled on each tile independently with different results. I've enabled a debug function I use during development so we can see what's happening behind the scenes. In this folder, we have the empty fusion mask, the soft merge that doesn't use fusion, and the feather mask applied when stitching the images back together, which is what causes the artifacts and ghosting. Nah, you gotta see what this spit out. Looks pretty solid. Not mind-blowing, but hey, no seams. Now check out what happens with high denoise. Oh boy. The scene looks intense, but notice the artifacts. Those overlays are creating ghost effects, which makes sense when the tiles don't share the same content. With just 6 tiles, it's still manageable, but imagine 100 of them. Creepy seams everywhere, tiles with different texture interpretations and color shifts. Definitely not production ready. Let's make it harder. We try a noise injecting sampler. Remember, that means multiple model loads and noise injections per step. It's like running 3 refinements at once. But now, problems multiply. Later, we will compare this with the other Fusion results. Keep in mind, all these tests are just to demonstrate the different tiling functions. We're pushing things to the extreme, so it's easier to see what's happening. We've also disabled all conditionings like control nets or style transfer. This is purely model sampling with IMG to IM seam. The difference between the fusion techniques shows up best with full freedom and denoise set to 1. We can clearly see how the blending behaves. With the commonly used feather mask technique, the seams become unstable. Let's move on to our second method, tile fusion. This was our first attempt at using AI to handle the fusion between tiles and move beyond the old transparent blending trick, and it's still one of the best ways to preserve consistency while adding detail to the original image. Here's the idea. Instead of simply blending tiles with a mask, each tile is given a bit of its surroundings, a reference area that pulls in content from neighboring tiles, so the tiles know what's around them instead of ignoring it. That means no more artifacts, no more ghosting, and richer detail, since we can raise the denoise without fear where it actually matters. So we had to give the mask preview a total glow up. While making this tutorial, I realized the old one was about as helpful as a GPS that only says good luck. To fix that, I threw on a fabulous pink frame for the stitch margin, a black frame for the overlap, and even dropped in a second image so we can overlap them like a badly stacked sandwich. Boom! Instant clarity. And while I was on a roll, I went ahead and added the missing upscale image preview to the tile node too, because hey, why stop at one upgrade when you can sprinkle in some extra magic? Here you can see it in action. We start with all set to 0 and we will add first, just to see it better, a bigger border, maybe a bit bigger. All right, let's zoom in. You'll notice a few colorful outlines here. The fusion border is glowing orange, the overlay square is a black line, and the final composite crop stitch line shows up in pink. Now, first question, why is that border orange and not green? Well, in Tile Fusion land, the fusion actually sits just outside the crop stitch line, and anything outside that pink line gets slapped with a compositing overlap. In this preview mode, when fusion overlaps compositing, it turns orange. It's basically saying, hey, I'm here too! And here's a neat trick. If we line up the black overlay lines, you can actually see exactly how the tiles are being handled, what gets cropped out, and what stays in play. But don't worry, this orange zone will get cropped away in the final image. You won't see it. What it does do, though, is sneak some extra content into the sampler during generation. That way, while each tile is cooking, it gets a little shared flavor from its neighboring tile, kind of like two chefs sharing the same spice rack. But first, let's set up a good working example. We're going to push the compositing mask down to 0, basically forcing a hard blend so we can really see what's happening. Fusion blur gets set to 48, fusion shift in out also 48, and we add a small 16 pixel border. Now, zoom in and check this out. With the fusion shift matching the blur at 48, we're actually sliding the blur inside the inner tile. That means this part will end up in the final image instead of getting cropped out. Notice how the black overlap margin isn't far from the crop stitch line. That tells us we're getting fusion overlap from both tiles visible in the final result. Now, let's bring back our little trick, lining up the overlap line and watch the magic. One tile fades its fusion blur from 100 down to 0, while the other ramps up from 0 to 100. Right in the middle, the zeros meet like two awkward teenagers at prom. So is that good? Not really. Remember, 0 means full freedom. Wherever fusion hits 0, we're basically trying to slam one full creative image straight into another full creative image. And spoiler, they don't fit. The result? A harsh, jagged tile border that nobody asked for. To fix it, we need to shift the fusion top left to line up that 100 pixel border. For two tiles, that's 48 plus 48, 96. Check the preview. The stitch crop line sits perfectly over the other, and the fusion blend ends exactly on this line. Result? A seamless join. The seam hugs the original image like a sneaky foo-foo denoise along the line, perfect for clean, consistent upscales. Not so perfect if you want wild, creative chaos. But don't worry, we'll get to that later with the big guns, Neuro Generative Fusion, which handles things in a totally different, way more creative style. Up to this point, we're not using control net or style transfer, just straight, consistent upscaling. But now you can start combining higher denoise, tile fusion, plus control net for even more controlled results. But first, we're going to use this point to show you how to integrate mask attention to define objects, repair seams, or even do a complete fresh in-painting in one area. Let's start with a setting that already has visible seams and repair them generatively using our mask attention node. We'll also convert mask segments into tiles as part of the process. Look closely. Here we've got visible artifacts, plus some text that looks like it came out of a glitchy typewriter. So here's what we do. We go to the input images, open the mask editor, and add separate masks for the areas we want to modify. I select the seam areas and also the artifacts. You can even select entire objects to in-paint or maintain, depending on whether you want more or less consistency. Once that's ready, we plug the mask into the mask attention node and connect this node to both the upscaler and the tiler. This will generate one tile for each mask segment we created. Now, maybe some of you are saying, oh, Sarah, I can just do this later with normal inpainting. Sorry, haha, nope, this is not the same thing. This method is special because it uses the original input image as the base for the process. If you just take the final image and inpaint on that, you lose the backstage input from the original. It's a big difference, completely different process, and of course, different results. Next step, let's set the denoise value for the segment tiles. At first, I'll keep it around foo-foo to stay close to the original, but then I change my mind. Seams are in-painting areas, so let's set them higher. That way, they'll fuse naturally into the surrounding content. If you want the perfect result, you can even add the exact seed you like. A neat trick, test the segment first with the fast preview in the refiner, then copy the seed you used and paste it back in. You can add prompts, adjust control strength just for these elements. So yes, you get a full set of controls to repair, maintain, or even invent new details inside the mask area of your final image. Remember, this is tile space. That means it's best to keep your segments smaller than a tile, otherwise things can get weird. Let's check the output images. And voila! The seams are repaired, the artifacts are corrected, even with the full freedom setting on the seams. But let's not stop here. Let's use the same tool for more fun changes. Back to the input images. This time I'm masking the car, the sign, and a little plant. The mask editor takes its sweet time, so maybe make yourself some tea while it loads. Once that's done, we go back to the tiler, activate the prompt generation, and run the workflow until the prompts are generated. Now inside the tile promoter, we can introduce our changes. For the bush, I took the prompt, pasted it into an LLM to rewrite it with blossoms, and pasted it back in. Raised the denoise so it has the freedom it needs. For the sign, changed it into a blue P parking sign. For the car, I actually wanted to maintain it more exactly, so I lowered the denoise instead of raising it. These are just examples. You'll find a lot more ways to use the mask attention node if you play around. Be creative! For instance, you can hook up an automatic YOLO or SAM2 selection to grab all characters in a render, and boom, you instantly get a mask for each person. The segment input is fully compatible with the Impact Pack nodes, so you can automate selections in all sorts of ways. Everything is possible. So far, good pep talk, but let's look at the image. The car changed exactly as we wanted, but the sign and the bush? Nope, no changes. Let's investigate. Oh, oops, I forgot to disable the prompt generation, so my custom prompts were overridden. Easy fix, just paste the modified prompts back in. And now, for testing, I'll use the fast one-tile preview. This way I can quickly try out a few seeds until I get the exact look I want. Once I find the right seed for the sign, I copy it from the refiner and paste it into the tile promoter. Same goes for the bush. Now, small problem, the bush image looks blurry. Why? Because the bush is tiny and the input image is noise. Later, more on this. So here's one type of fix. Add finer details using the enrichment pipe and scale all segments by 2.c before sampling. And yes, do the same scaling for the tiles too, otherwise you'll end up with different detail definitions across the image. Take care. Each change in mask or size will change the result of the final tile. And there you have it. Seams gone, artifacts fixed, new blossoms on the bush, a proper blue parking sign, and the car still original. This is the power of the mask attention node. Not just a tool, but a full creative workflow. Did you notice everything was super noisy until now? Let's dig in and fix this mess. First, we hop over to the input images, and yikes, look at all that giant chunky noise left over from our first heavy Res2 noise injection upscale. How do we get rid of it? Well, I hope you already know this magical place, the Open Model Database. Seriously, it's like a candy store for upscaling and denoising. Anything you can imagine, it's there. We just need one denoiser, 1x only, folks. I've already stashed a few in my ERScan folder inside ComfyUI.miles. Now, here's the twist. We're going to use the Upscaler plus Tiler as a denoiser. Surprised? Not really. Step 1. Upscale the image with our model. Then select 1x RGB max denoise and run it, but only until the Tiler node. Here's where a software update came to the rescue. I needed a preview of the Upscaler before tiling. You'll see it's denoised, but oh no, all the juicy details are gone. Swap the denoiser to my secret weapon, 1x noise toner uniform detailed, hit run on the group node, and voila! A beautifully denoised image ready for enhancement. Then go back to the input images node and pick this one as your new input. Finally, set the tiler back to upscale without a model and let it work its magic. Now we're cooking with the best fusion method ever. Hey, finally, we're here using the Neuro Generative Fusion method. And let me tell you, this one needs a totally different setup. Watch me. We set Fusion Blur to 48. Fusion Border, honestly, it doesn't do much, so we'll leave it at 0. Okay, that's what we get. See that green Fusion Blur all around the tile? Here's the catch. Neuro Generative Fusion no longer looks at the original neighbor tiles. It only checks the tiles that are already generated. So, we tweak the top left to 548. Why? Because we want to ignore blending with the right and bottom tiles. We've got enough input from IMG to IMG already. No need for extra chaos from those sides. Check the result. Fusion only happens on the left and top. We can add a bit of compositing, which shows as a soft yellow over the edges. Smooth, seamless, perfect. This setup gives us high denoise, seamless fusion, and now we can jump straight to fine-tuning other stuff. Let it run, and I'll show you the overlapping function again. The black line is the reference overlapped border. And as before, when we align these black lines, we see how the tiles overlap. In Generative Tile Fusion, the following tile will always overlap the previous tile. The right and bottom borders of the previous tile get lost. The green Fusion Blur shows where the following tile blends all its creativity into the previously generated one. At these borders, both are perfectly fused. No cropping is needed because the overlap Fusion border combo creates the perfect AI-generated seam for us. This gives us beautifully relit and well-defined images, plants, trees, details, all improved. As before with Soft Fusion and Tile Fusion, we test different settings. The first is just Euler simple with 0.5 denoise. As you can see, the overall detail result is the same as in the other versions with 0.5 denoise, but now we don't have to think about seams and artifacts anymore. Let's also do a noise injecting Res3's sampler test. For this, I had to involve my software team because we didn't have a dedicated sampler input in the refiner node, and for what I'm doing now, I needed one. The normal Res samplers have fixed noise injection settings, and this can often be too high, but the Res suite offers the downsampler node, so we can adapt the noise injection, whereas I do here, set it to 0, because the resampling of the Res sampler alone is already excellent for detail generation. I just have to activate the bypass sampler here, set the noise to 0, and select Res 3s. We'll make another time jump to the results of these settings. Did you know that in the Res sampler, S means it calls the model many times for each step, while M uses just one model call at each step, but both still do extra refinement repetitions? So the Res 3's refinement result, we'll quickly go over the images, focusing on the more interesting parts. While you decide whether it's too much or just right, I was about to tell one of my nerdy jokes. Okay, you're right, no joke now. Not in such a special moment, haha. Now, I have a very nice surprise for you. I took the time to set up a workflow with all the steps we've done so far as a fast one-click workflow. And again, the software team had to jump in and fix the tile promoter so it could work with more than one instance. We did this, and now we can chain the process. Finally, we also added magnific upscaling. Here's the workflow and its main steps: denoising, refinement, upscaling, and upscaling again. We'll test this workflow using our latest announcement, the per pixel denoise mask. Do you remember? We fixed the open issues, and now we hope that the per pixel denoise mask can fully replace the denoise settings and segment to tile method in a very easy painting approach. Let's load my pre-prepared grayscale map into the workflow. You can see that I made all the surrounding plants black, so they'll be fully rebuilt. The car gray, so it will be refined but maintained. The sign light gray, so we tell the model to keep the sign but make it a bit nicer. The background middle gray, so it can change a little, and the building lighter middle gray, because we don't want the model to alter large elements in our ArchViz rendering. Darker means more freedom. This mask has to be plugged into the refiner node, and we also have to activate the map with the complexity mask strength. If we leave the strength at 0, it will be ignored. If we set it to 1, it's fully activated. The map will then be multiplied by the denoise we set in the refiner. So if you drew your grayscale mask already with exact denoise values, 1 is white, 0 is black, then you have to set denoise to 1. In my case, I used black for the trees, but I don't want denoise 1. I prefer 0.8 on the trees. So I set denoise to 0.8, and the mask will interpolate to a maximum denoise of 0.8. So far, so good. Are you following me? I told you, it's a long but exciting video with lots of hidden treasures. With our Res 3's noise injection in place, each step of refinement gets its own creative boost. It's like running 3 mini magical upscales at once, but controlled chaos, darling. Let's see the final workflow all together. We start by denoising the original image in the same way as before. Don't worry, I'll add this workflow to my Patreon. It's the best place since everything is set up for pro functions. You'll need at least the free membership and an API key to get started. The API is really easy to set up. On my Patreon, you'll also find a video for that part. Okay. Back to the workflow, the next step is refinement with Neuro Generative Tile Fusion. Set it as you like, depending on how wild or controlled you want it. After that, we do as many upscaling and refinement steps as you like. I added 2 steps, each doubling the image size, and you can add another for a final mega upscaling. I'll show you some of the results we got, but remember, you have to decide how to fine-tune your results. Every step feeds into the next, fully synchronized. Here's the beauty. You can control almost everything with the Denoise masks. Want softer plants, but a crisp building? Done. Car original, but the sign vibrant? Easy. Even the tiniest leaf can have its own freedom level thanks to grayscale mask control. Darker, more freedom, lighter, more constrained. Genius, right? And voila, the final output, seamless, sharp, and beautifully coherent. Every leaf, window frame, and texture detail is perfectly integrated. The bushes have blossoms, the parking sign is perfectly blue, and the car remains exactly as intended. No seams, no ghosting, no haunted broccoli. I'll upload some of these images so you can compare the methods. Do you know now what to use first? Here's what I think: the first refinement should be the most creative one, generating everything the current resolution can handle. Don't jump into upscaling if you can still refine at the same resolution. You can often refine more than you think. Then, when you go bigger, stay creative, but maybe reduce creativity later, because if the LLM can't recognize the content of each tile, it may get irrational or give empty results. At that point, switch to a less creative method. And for the last step, try using a soft merge with 0.20 denoise. Quick tip, always check small details with the selected tile preview. Tiny tweaks can have huge effects across the composite image. This is especially important when working with high denoise or small segments. Finally, remember, this workflow isn't just about upscaling. It's about control, refinement, and creative freedom. Mask attention plus enrichment pipe plus noise injection plus tile or neurogenerative fusion plus grayscale maps, a full pro-level creative workflow. You can push it further with ControlNet, style transfer, or extra prompts in Tile Promoter, but that's your creative playground now. So grab your coffee, put on your favorite music, and start experimenting. With TBG Enhanced Upscaler and Refiner, you can finally turn any ArchViz render into a masterpiece where every element gets its moment to shine. And there you have it, folks! All the magic of mask attention, tile fusion, neurogenerative fusion, and noise injection wrapped up into one glorious, crisp, seamless ArchViz workflow. Now, a proper Sarah-style joke for you. Why did the AI refuse to join the orchestra? Because it couldn't handle all the noteworthy stress. Ha! And hey, quick confession time. Yes, I'm TBGS's AI-generated Sarah, your ever-enthusiastic, slightly over-caffeinated guide through this crazy long workflow. Honestly, this is the longest tutorial I've ever made. And let me ask, is someone really watching until the end? Remember, this was part 2 of our TBG Eater ArchViz series, so don't skip part 1 or you'll miss the foundation for all this wizardry. In the next video, we'll go full-on, all-in-one workflow, denoising, refinement, and mega upscaling in a single, elegant pipeline. You won't want to miss it. If you loved this deep dive, don't forget to like, subscribe, and hit the bell on YouTube. And if you really want to support our crazy AI adventures, check us out on Patreon. Every little bit helps keep the magic flowing and maybe a few haunted broccoli-free trees in your renders. All right, go make some crispy, seamless, beautiful ArchViz renders, and I'll see you in the next one. Bye! Don't forget to download the new version. It's available on GitHub or in the manager. I have one more example about the Fusion strength parameter. We already talked about how it works. By default, the green line shows how blending moves from the border into the inner tile. If you change the Fusion blur, it looks like this. If you change the Fusion border, it looks like this. Very straightforward. Fusion strength, which you asked me to explain more clearly, works like this. Values between 0 and 1 adjust denoising inside the tile, while values from 1 to 2 control how strong the blending is at the border. And one last little cheerful wave. Bye-bye again. Happy upscaling, and may your tiles always blend perfectly.